So I'm going to be talking about vectors, the ones that we call columnar vectors, right? Okay, fine. I'm going to be leaving out the other part of the vectors, like the big ones, like the ones that we call Gaussian vectors. So I'm just going to be talking about these ones, right? So let's say we have P is equals to 3, 4, and Q is equals to -4 and 5. And then the question asks is you to find A, P plus Q, B, P minus Q, C, 2P minus 3Q, D, modulus of P, we call that modulus, or we call that magnitude, modulus of Q, and then let's say modulus of P plus Q. Now we want to do something like this together, right? Until you get these things right. So the first one is P plus Q. You just take the vector of P, which is this one, and the vector of Q, and then you add them. 3, 4 plus -4, 5, right? So we say 3 plus -4. That's literally plus and minus. We're going to get a negative there. So it's 3 minus 4. It's going to be -1. 4 plus 5, we get 9. So this is literally what we are looking for, right? So I want to keep this one so that we will be able to see our questions here. So let me just put it like that. Alright, fine. Our B is saying P minus Q, right? So let's say P is 3, 4 minus Q is -4, 5. Let's say something like that. So we say 3 minus -4, minus becomes a positive, so it becomes 7. 4 minus 5, it becomes -1. This is our answer here, right? And then C is saying 2P minus 3Q. Right, this one we call them scalar vectors because we have these numbers here. They are acting as scalars. We call them scalar vectors, right? Because these numbers are going to multiply our vectors first before we either add or subtract. So 2, P was, we come back here, 3, 4 minus 3. Q was, we go there, 4 and 5, something like that, right? So we multiply there, we multiply here, minus, we multiply there, we multiply there. So we will end up saying 6 minus -12. Obviously 6 minus -12, I'm pretty much sure you know negative becomes positive, so it becomes 18. 12 minus 15, it becomes -3. So this is our answer here, right? Okay, I'm sure you guys you're following. Let's go to the next page. Now we want to work D, that is say modulus of P, right? Modulus of P is just a magnitude, or in vectors it's sort of like the distance. So we say 3 squared plus 4 squared, something like this. Then we say 9 plus 16, something like this, and then we say that's going to be 25. So we will get square root of 25 is 5. We will get something like that as our final answer, right? Okay, fine. We also want to find, that's E, modulus of Q. Modulus of Q, say the distance, we're going to say here, and then we have Q. What is our Q? Q is our vector 4 and -4 and 5, -4 squared plus 5 squared, something like that. That's going to become 16 plus 25. It's going to become, if we add that one there, it's going to be 11, 41. We can't really work out the square root of 41, so we leave it in this form. Usually we say it's in Z form, and right, it's in Z form. We just leave it like that, right? Okay. I hope you guys you're understanding what I'm doing right now, right? Now I want to do the one that is saying I want to do the one that is the modulus of p plus q, right? All right, anyways, we found out p plus q was, we worked p plus q here, right? Now it's here. No, it's not even here. Where is our p plus q? P plus q is right here. We worked it here. So p plus q, we got -1 and 9. So if we're going to have to find the modulus of p plus q, we're going to say -1 squared plus 9 squared. And then we say that's 1 plus 81. We say square root of 82, something like this. Square root of 82, right? Now we can't really work the square root of 82, so we're just going to have to leave it like that, right? So these are the most simple vectors. We call them columnar vectors, right? We're not done yet. Let's do other types or other examples. Okay. Let's say the question say if 2cx is equals to 10, 8, and then the question says find cx, something like this, right? We want to find something there. All right, fine. So we have 2cx is equals to 10 and 8. We only want to leave, we only want cx this side, so we're going to divide by 2. We're going to divide by 2, so we get cx is equals to 2 into 10 is gonna be 5, 2 into 8 is gonna be 4. We're not done yet. Remember, we want something like cx, modulus of cx, right? Now when we worked out cx, we got this 5 and 4, so we're going to say 5 squared plus 4 squared. We're just going to get 25 plus 16. We're going to get 41 again. Something simple like that, right? Okay, let's say we have something like OA is equals to 3 minus 2 and OB is equals to 4 and 5. And then the question says find AB, right? So if you want to find AB, you just say vector of B subtract vector of A. Now what's our vector of B here? So we go on and say AB is equals to OB minus OA, something like that. OB it's 4, 5 minus OA it's 3 minus 2, something like this, right? So 4 minus 3 is going to be 1. Minus minus is going to be positive, so we get 7 if we add 2 and that other one there, right? So that's how you get something like AB, right? I'm pretty much sure you guys are following up, right? So if you know, if you have understood all these things, that means that you now know vector 1, right? I'm going to have to leave you an exercise which you can write, and I'll mark for you if you want. If you don't want, it's okay. You can just tell other people about our videos so that they can benefit from them too, right? Okay. Alright, so you guys, I'm pretty much sure you have understood what I taught you today about vectors. If you did not understand, you can rewatch the video, right? If you have any